Hello everyone, today in this video you're going to learn about data and CPU. So it's actually about working with binary. Now the first starting we are going to take with the introduction of bits, bytes and base 2. Now we use a number system that is called decimal. Decimals are simple numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9. Decimal is also called the base 10. Base 10 is a useful term because it reminds us that there are 10 digits used in the number system, decimal number system, which is 0 to 9. 10 is not included. From 10 onwards, we are making combinations of the numbers from 0 to 9. Meaning that if you look at the digit 10 itself, so it is making a combination of 0 and 1, like 1 and 0, 10. So on 10 onwards, all the numbers are making combinations of the numbers from 0 to 9. The value of each digit in a number increases by 10 times as you move from right to left through the number. The computer's microprocessor is a small component made up of millions of tiny electrical switches, which are actually called transistors. Like any switch, a transistor can only be either on or off. So a computer stores and processes data in a simple format because it only understands these two states that the transistors are telling, which is either on or off. So the simple format the computer uses is binary. Binary denotes on and off by using two digits, 0 and 1. So on is denoted by 1 in the binary system and off is denoted by 0. And the binary system only uses zeros and ones to represent data, which are two digits. That is why we called binary as base 2. This base 2 is a useful term because it reminds us that there are two digits used by the binary number system, which are 0 and 1. And the value of each digit in the number increases by 2 times as you move from right to left through the number. Which means if you're putting powers, for example, if you're putting 2 is to power 1, 2 is to power 2. Why are we using 2? Because binary is a base 2. That is why. 2 is to power 3, 2 is to power 4. Now if you see their results, it's that they are 2 multiplied by 2 is 2. Now 2 multiplied by 1 times is 2. Okay, and 2, when you're multiplying this, 2 multiplied by 2 is 4. Then 2, you're multiplying it 3 times. 2 multiplied by 2 multiplied by 2 is 8. And then 2 multiplied by 2 multiplied by 2 multiplied by 2 is 16. Now when you see a difference, it's of 2 numbers. Sorry, it's a multiplying by 2. Like you're multiplying 2 by 2 by the base 2 to give you 4. And you're multiplying 4 by 2 as it is the base to get 8. And you're multiplying 8 by 2 as it is the base to get 16. So that is what this thing means. Now, bits and bytes. A binary number is denoted by 0 and 1. If this is my binary number, a binary number only ever contains zeros and ones. Each 0 or 1 in a binary number is called a binary digit. In computing term, the term binary digit has been shortened to bit. So bit actually means 0 or 1. A bit is too small to be of practical use to the computer, so the computers use group of bits together. Computers group bits together in the same way we group letters to make words. The basic word that a computer uses is 8 bits long. Each 8 bits is called a byte. When you write binary numbers, you always write them as full 8-bit. 8-bit bytes. Even if that means adding zeros to the start of the number. For example, in binary you would write the decimal number 2 as even though the number like here, even though your number is only coming 10, but you're still gonna write 6 more zeros to make this an 8-bit number. Now let's look at the 8-bit binary digit table. Now this is what actually it is. To find what the number, the decimal number is, you always use either the repeated division method or the table method, which is by using this. So for 93, 93 is smaller than 128, so that's why we're putting a 0 over here to mark it off. But it is greater than 64, that is why we're opening 64. Then we're going to do is 93 minus 64, which is a 29. Now 29 is greater than 32, that's why we're putting a 0. Then but it is greater than 16, that's why we're putting 16 over here. Then we're going to subtract 16 from it as well, and then we get a 13. That's why we're opening the digit 8, as it is like 13, as it is less than 13. Like we have to, then we're going to subtract 8 from 13, which gives us 5. Then that's why to make 5 we're opening 4. Then we are getting 1 left, so we're opening 1 as well, and 0 and 2 has remained close. So we have to like add all these numbers to get a 93. That's why we have to make possible combinations. But this is all done by subtraction. How you're getting this is by subtraction. Now if our decimal number is 159, then we have to open 128 over here, as it is less than 159. Then when I subtract 128 from 159, I'm getting 31. So I cannot open 64 nor 32, but I can open 16. And if I subtract 16 from it, I'm getting 15. So I can open 8 as well. Now I'm subtracting 8 from it, and I'm getting 7. So I can also open 4. And then I am getting 3. So I can open these two as well. So this is what 159 is in decimal number, or sorry, in binary numbers. If we want to confirm if our answer is right, then we have to add 128 with 16 with 8, 4 and 2 and 1. We are adding that. You can quickly add it on your side. Come on, add it, and you can confirm that if it is adding to give us 159. Yes, it is. So we're going to do it with the repeated division method. As binary's base is 2, so we're going to take out the LCM by using 2. So 2, 104, 2s are 208, then 2 5s are 10, and 2 2s are 4. There is no remainder left in this, so we're going to put 0. No remainder left, put 0. Then 2 2s are 4, and 6 are 12. 6 are 12, then 0, no remainder left. 2 1s are 2, and 2 3s are 6. 0, no remainder left. Then 2 6 are 12, the remainder is left 1. And then 2 3s are 6, no remainder left. 2 1s are 2, and 1 remainder left. So how are we going to write this from here to here? 1 1 0 1 0 0 1, 2, 3, 4. It's like that. Now, how are we supposed to confirm if our answer is right? We can put it in the decimal, so in the table method to find out about that. So that is how we can find, like, we're going to add 128, 64, 16, so that we can confirm if we get 208. And so we have confirmed that we're getting 208. Now we can also verify